So hyperbolas, as I mentioned before, look kind of like double parabolas. They're really a different shape than a parabola because a parabola doesn't have an asymptote. It just keeps curving and going wider and wider and wider. But a hyperbola actually approaches two asymptotes. So if you had asymptotes like this and like this, your hyperbola is going to approach those lines, and parabolas don't act that way. Parabolas don't approach being linear. And so that's a major difference between parabolas and hyperbolas. Not only the fact that hyperbolas have two of them, but their shape is getting closer and closer to linear as I move away from the origin. Okay, so we have a center point still at the origin, 0, 0. We would have a focal point at A0 and that's a vertex at A0 and a focus at C0. So the distance from the center to the focus, we're still calling that C, just like we did with ellipses. Okay, and this, let's see. This is the equation that we use to find C. So C squared equals A squared plus B squared. Remember, for ellipses, it was the difference between those, but here it's addition, not subtraction. Okay, so that's a difference in the equations. And this is the equation of a hyperbola if it has a horizontal focal axis. So that means the foci are horizontal from each other. If the foci are vertical of each other, then this is the equation we get. Okay, so a way to remember that, if it goes in the x direction, x comes first. If it goes in the y direction, y comes first. And that's the positive term that is first, and then we subtract the other term. So it's a subtraction sign here, whereas for ellipses, that was always a plus. But for hyperbolas, it's always going to be a minus between the two terms. Okay, so let's see how this works with a couple examples. So for example, 5A, first we want to put it in standard form. So just like with ellipses, we want a 1 over here. So we're going to divide everything by 144. And we get 144 over 9, or 9 over 144 is 1/16. So this is x squared over 16 minus y squared over 9 equals 1. Okay, and the way that we graph a hyperbola is it starts off very similar to graphing an ellipse. So if this was an ellipse, we would have the origin here. We would go 4 in the x direction, and we would go 3 in the y direction because it's 3 squared underneath y. So that part is just like for an ellipse. But instead of drawing an ellipse here, I'm going to draw a box. And that box is going to guide our asymptotes. So if you draw now lines through the corners, those are going to be asymptotes for our hyperbola. Now, since this one since the positive term is the x term, we know it's going to go in the x direction. So we put our vertex right here on the edge of the box, and we approach the asymptote. So when x is the positive, it goes in the x direction. Here's another vertex. It's going to approach the asymptotes from there. And so that is our graph. And now we can find the focal points by saying c squared is equal to 16 plus 9. So that's the sum of the two denominators. C squared equals 25. So C equals 5. And so if we go from the center, we're going to count. Here, let me change color, pen color. We're going to count 1, 2, 3, 4, 5 units from the center. There's our focal point at 1, 2, 3, 4, 5, 0. And then if we go 5 units in the other direction, 1, 2, 3, 4, 5, There's another focal point at negative 5, 0. And so notice that, again, the hyperbola wraps around its focal points, kind of similar to what parabolas did. Okay, so we have our graph and we have our focal points. That's all we were asked to do with that one. Okay, so now I would like you to pause your video, try example B, and press play when you're ready to check your graph and your focal points. Okay, if I divide both sides by 225, then I get y squared over 9 minus x squared over 25 equals 1. And so since the y is first, this is going to be a vertical hyperbola, meaning it's going to go up and down. And so we go 3 in the y direction, 5 in the x direction, draw our box, draw the asymptotes through the corners of the box. And since this is a vertical parabola, since y is the positive, since the y squared is the positive term, it's going to go up and down. So we're going to approach the asymptotes from this vertex. So the vertex is right on the edge of the box, and then it approaches the asymptotes. So we're also going to have a point on the edge of the box here, and then the curve is going to approach those two asymptotes. So that's our final graph, and then the focal points are not on the longer axis. They're always inside the curves, and so they're going to be somewhere here and here. Wouldn't make sense to put the focal points like here and here because the hyperbola has to wrap around its focal points. All right, so c squared is equal to 9 plus 25. Remember, it's plus for hyperbolas. It's subtraction for ellipses. And so c equals the square root of 34, which is about 5.8. So since the y is the positive term, the y squared over 9 is the positive term, our c goes in the y direction. So if we count up 1, 2, 3, 4, 5.8, that's right about there. And then back to the center, go down 1, 2, 3, 4, 5.8, be right about there. And so this is a focal point at 0, root 34, and this is at 0, negative root 34. One thing that we didn't do for both examples, it does say to write the equations of the asymptotes. So we skipped that for question 1. We can get the equations of the asymptotes just by looking at the slopes of these dotted lines. So in order to go through this corner of the box, we had to go rise 3, run 4. Rise 3, run 4, so that means the slope is 3/4. So the equation of this asymptote is y equals 3/4 x. This other asymptote, we're going up 3 again, but we're going backwards 4. And so rise over run is going to be y equals negative 3/4 x. So those are the two equations for the asymptotes. Okay, for example B, we're going up 3 and over 1, 2, 3, 4, 5. So up 3 over 5, up 3 backwards 5. So our equations of our asymptotes are y equals the slope, which is plus or minus 3/5. Yep, 3/5 x, and that describes both of the equations of the asymptotes. Okay, for example 6, this time we're given the focal points and the asymptotes. So excuse me, focal points at plus and minus 4, 0. So here and here. Asymptotes at up to and over 3, down to and over 3. Up to and backwards 3. And down 2 and backwards 3. And so that means our box would look like this, with asymptotes going through like this and like this. And the vertex would have to be here to wrap around its focal point, and here to wrap around that focal point. So we see now that this is a sideways parabola, so it's going to have to be x squared. So it's going to be x squared over this distance, which is 3. So x squared over 9 plus y squared over, this is 2, so that's going to be 4, equals 1. Okay, go ahead and try B. Pause your video. Sketch this out, and then see if you can write the equation. So we have vertices at plus and minus 2, 0. So those are vertices, which means our hyperbola has to be going this way. And the asymptotes are, they have a slope of plus and minus root 3, so that means we're going up root 3 and over 1, up root 3 and over 1. And so our box for our asymptotes would look something like that in order for the asymptotes to have the correct slope. Okay, and so this is 2, and this distance this way, or sorry, that's 2, and then our rise had to be 2 root 3. So run 2 and rise 2 root 3 gives us the slope of root 3. And so our equation, since it's going sideways, it's going to be x squared over this distance. So 4, 2 squared is 4. And then y squared with this distance, which is 2 root 3 squared, equals 1. So that's x squared over 4 squared, or 16. Sorry, 4. 2 squared is 4. And then if I square this denominator, I get 4 times 3 is 12. Equals 1. We can also shift hyperbolas the same way that we shifted ellipses by replacing x with x minus h and y with y minus k. So the equations you have here are the same as the ones we used at the beginning, like x squared over a squared minus y squared over b squared equals 1. That's a hyperbola centered at the origin, whereas this one has its center at HK. And same with this one. This would be a vertical hyperbola, and like this, whereas this one is sideways like this. Remember, since x comes first in this one, since this is the positive term, it goes in the x direction. This one has the y as the positive term, so it goes in the y direction. And so this one also has center HK. So with that in mind, go ahead and pause your video and try example 2 with the shift of the center. And after you're done graphing it, then find the foci and the equations of the asymptotes. Press play when you're ready to see the solution. So our center for this one is at -1, 4. And so we'll start with that, -1, 4. Center is here. And then this tells us we're going to go 2 units in the x direction, 1, 2, 1, 2. 3 units in the y direction, 1, 2, 3, 1, 2, 3. We'll draw our box there. Draw the asymptotes through the corners of the box. And this one, since the x term is the first term or the positive term, it's going to go in the x direction. So we're going to have a vertex there and approach the asymptotes. Vertex there, approach the asymptote. Okay, and then c squared is equal to 4 plus 9, which is 13. So c is the square root of 13, and the square root of 13 is about 3.6. So from the center, I'm going to count out 1, 2, 3.6. That's about right there. So that focal point is going to be at, let's see, we started at an x value of -1, and then we added root 13. And the y value is 4. And then count 1, 2, 3.6 in this direction, put the other focal point there. So this is focus 1. Focus 2 is going to be at -1 minus root 13, comma 4. Okay, and now the equations of the asymptotes. We need the slope, so we can get that from the box. If we're at the center, we go up 3 and over 2, up 3 and over 2 to create this slope triangle, up 3 and over 2. So we know our slope is up 3 and over 2, or the other one would be, so it's plus or minus 3 halves, depending on which asymptote. So this one is a positive 3 halves. This asymptote has a slope of -3 halves. And then our center point again is at -1, 4. So if we do it in point slope form, we're going to have y minus 4 equals m, which is plus and minus 3 halves, times x minus -1. And so that's y minus 4 equals plus and minus 3 halves x plus 1. That gives the equation of both of our asymptotes. If you wanted it in point slope form, you'd have to separate them. So that would be y equals positive 3 halves x plus 3 halves plus 4, which would be y equals 3 halves x. Let's see, that's going to be 11 halves. Or if you do the negative slope, then you get negative 3 halves x minus 3 halves plus 4. And that's going to be y equals negative 3 halves x plus 5 halves. So those are the two equations in slope-intercept form, whereas this one gives both equations together in point-slope form. So that's it for today's lesson. Have a great day.